Hi, and good morning, everyone, or depending on your time zone, good afternoon or good evening, and welcome to this Digital Supplies webinar on color management, basic color management, because that's what we're going to do today. We're going to talk about colors and what it means or can mean to you and your customers, and then we'll have some demos of how we can use color management to get a better understanding of what is going on. So I prepared a small presentation. We'll start with that. Just on a side note, as usual, the chat is closed and chat will be opened at the end of the session for all your questions, and I'll be very happy to answer them. So let me just switch to my presentation. So it's about basic color management. We're not going to go too deep or too into details, but the goal of this session is that you should or would understand what it actually means, because there's a lot of mystery and strange terminology used when it comes to color management. And in essence, the problem of color management and the solution of color management is actually quite easy to understand. And so that's what I would like for you to do today. So let's first have a look at what is color management actually. So a lot of people say, yeah, it's going to help you print better colors, or it's going to help you print more colors. And both of these sentences are dead wrong. All right, it's not going to help you print better colors or more colors or whatsoever. What it will do for you is help you to predict how color will be printed on your printer, and that from the very start. From the moment you open your designs or your photos on your computer, you should be able to predict how they will on a specific type of media. Because, well, it's quite simple. If you can't trust the screen you're looking at, you don't know how the colors will look. So how are you going to do any color corrections in Photoshop if you can't trust the screen and if you have no clue on how these colors in your photos or designs will look on the printer? So we need predictability. And we also need to be able to control color conversions. We'll look at that in detail a little later. It takes out the guesswork, because in the old days, way before color management, people used to trust on their monitor, not because it was calibrated and they were using profiles, but because they were used to it. And they were like, okay, if this red looks like this, more or less on my monitor, it's going to look more or less like this on the printer. So color management takes out the guesswork. All right. It's going to save you time, because you don't have to print too much proofs, or you don't have to do a lot of test prints, because you know on your screen what you're going to get when it comes out of the printer. And that's going to save you money, not only because it's saving you time, but also because when you use color management, you also can get control over the way ink is used in your printer and how much ink is used. And you can use techniques like GCR and UCR, where you replace cyan, magenta, yellow by black. All right. So clear advantages to using color management, and color management has always been about predictability. All right. I want to be able to predict how color will look on different devices. So what's involved? Well, if you're going for color management, there's no way that you can have it half-half. Like I'll calibrate my screen and then that's it. No, you need to have your input, your screen, and your output calibrate. And on the bottom of this slide, under the pictures, I've put RGB twice and CMYK. And if you think about it, that's actually the real challenge or problem of color management is that you're going from one color space to another color space. You're going from RGB to CMYK. And I'll show you some examples that will learn you that RGB color spaces or gamuts, actually, I should say, are always bigger than CMYK. So translated, that means that you can see much more colors on your screen than your printer can print. So all these colors that you can see on your screen that are not printable by your printer, we need to do something with that. We need to change them. If we don't control that, they're going to get changed anyhow, okay? So it's much better to have control over that. So we defined what the problem is. The problem is that you're going from RGB to CMYK, and we're not going into details that RGB and CMYK, that one is additive and the other is subtractive, etc., etc. They're totally different ways of seeing or reproducing color, okay? And what we need to know is, like I just explained, RGB is always bigger than CMYK, right? So colors that we can see on the screen that are not printable, we call these out of gamut colors. And we need to have a way to control how these out of gamut colors come into the gamut of the printer, of course. All right. The solution is something called CLAB. CIE-LAB, or CLAB. LAB is a device-independent color space, and it sits in between RGB and CMYK when you use color management. So basically, the translation goes from RGB to LAB, and then from LAB to CMYK. Of course, if you open a photo in Photoshop and it's RGB, and you change the color mode to CMYK, you don't need to go by LAB. That's going to happen automatically and will be calculated by your computer and by Photoshop. But the advantage of using LAB is that you can have strictly defined colors in there, and that LAB can be used if you need to calibrate your screen. We'll have a screen calibration a little later, and I'll explain how LAB helps to get things going. All right. So devices involved, a colorimeter, like the one on the left, which is a Color Monkey Smile. But there are many others. You have the i1 Display Pro. You have the Color Monkey. What is it again? Color Monkey Display. These type of devices can calibrate your screen and anything else that emits light. Okay, so like a projector, for instance, if you would want that. But they cannot measure anything that reflects light. So if you have a piece of paper with some ink on it, light falls on the piece of paper, sorry, it gets filtered by the ink, and that's why you see a certain color. So that cannot be measured with a colorimeter. You need a spectrophotometer that can measure the spectrum of light, right? And I have two here. I have an i1 Pro, right? Which is a spectrophotometer and can be used for screen calibration and CMYK printer profiling. And I have a Color Monkey Photo. This device actually comes in two flavors. The one you see in the presentation, the white one, is a Color Monkey Design, and this is a Color Monkey Photo. It's also a spectrophotometer. It can be used to calibrate your screen and do RGB printer profiling. A little more on that later. On a side note, the difference between the Color Monkey Design and the Color Monkey Photo is only in the software. It's exactly the same hardware, but in Color Monkey Photo, the software is designed to be more tailored towards photographers, while design is tailored more to graphic designers and pre-press environments. As an added bonus in the photo, you do get a color checker, looks like this, and that can be used to calibrate digital cameras, okay? Hence the name Photo. So let's have a look on how screen calibration works, all right? Now, before we do that, I'm gonna go to Photoshop, okay? And my screen is not calibrated yet. Okay, so it's uncalibrated. And I have this picture, and you can immediately see that it has a lot of saturated colors in here, all right, in the arms, etc. So this picture, this particular picture, has a profile embedded, okay, by the digital camera. And usually, if you take a digital reflex camera, you will have the option to have either sRGB or Adobe RGB as the profile that will be embedded to every photo that you take with the camera. In this particular case, it's sRGB. If you work in a professional environment like we do, it would have been better to choose Adobe RGB because it's a larger gamut and because it is optimized for professional print and photo environments. sRGB is actually a profile. They took a bunch of cheap monitors and made an average profile of that, and that has become sRGB. And the reason why they designed sRGB was for the web. Okay, so you can see here on the bottom that it has sRGB as the input profile. And if we take a look at my color settings, you will see that my working spaces are Adobe RGB, but since I have sRGB as the input profile or the embedded profile of this picture, calculations will be from the sRGB profile. And for CMYK, I have Euroscale coded, which is actually a profile for the offset printing press in Europe. Okay, now not much use to us, but it will help me show the function in Photoshop that shows you the out of gamut colors. So we have a bunch of colors now in this image that the screen can show, but that the printer cannot print. And if we go to view and we ask for a gamut warning, then everything that is colored gray now are colors that cannot be printed on a Euroscale coded profile printing press. Okay, and with these, well, I could start doing color correction while the gray is displayed, but that's a very bad idea because I don't really know what I'm doing then. So instead of using gamut warning, I will ask to proof the colors. And you see them changing. If I go back to not proofing, yeah, the very, very bright red, and I go back to proofing, I can use Command Y as a shortcut for that. And you see that everything gets a little bit more dull. It also shows it in the name of the picture that this is an RGB picture, but I'm looking at it with the profile Euroscale coded. And now I can start doing my color corrections like this and try to get more red in here. You see, like that. That's too much, etc., etc. So if I go back to gamut warning and I do the same, you will see that it does have an effect. Okay, if I make it like this, you can see that a lot of the gray is going away or coming in depending on what I do. So that control over or at least it gives you an idea. It helps you predict how colors will look on your printer or a specific printing press in this case. But I could also set up my soft proofing environment because that's what we're doing, soft proofing. And proofing is just printing a proof on a printer, on a proofing printer like an Epson. Soft proofing is doing the same but on your screen. So if I go to proof setup custom and instead of using my working CMYK, which is like a default CMYK space because it's set in the preferences, I go to one of the profiles I have in here, like a GV33 on specific redrama. Okay, so now I'm doing soft proofing, looking at it with the profile of a Mimaki GV33 printing on redrama media, specifically redrama media. So again, not proofing, proofing. You will see that the effects of it, especially when I put on the gamut warning, it's a lot less. You don't have these big bands of gray anymore. And in general, an inkjet printer has a much larger gamut than a CMYK printing press. That's the reason, right? And especially if you have a printer that also uses N-channel colors, like it has red ink, orange ink in there, or red, or green, then that expands the gamut as well. Right. So don't prove the colors, don't do a gamut warning. So let's have a look, because there was one big omission here while I was showing you how to do soft proofing and look at gamut warnings and out of gamut colors. There was one big error here. My screen is not calibrated. So I can do a prediction, but if my screen is not calibrated, then it doesn't mean much. So let's have a look on how we can do that. And I'm going to use the Color Monkey photo to do that. So let's start the software. You don't need to check. Hide everything in the back. So let me quickly switch. Yeah, just to verify that you still see my shared screen. And I'm also going to, maybe that's a better idea. I'm going to switch it like this. So make this big. Yeah. So that you actually see what's happening. Like this. So back to the Color Monkey software. All right. Now, in this particular case, I'm going to profile my display. Okay. So let's go there. And it's an LCD. Okay. Well, actually, it's a laptop, so I'll switch it to laptop, but laptop has an LCD screen as well. I can use the easy road, and that will just take you straight forward to calibration of the device and then measuring colors on screen. But let's go to advanced, because we have one important extra option when we go to advanced that we really need, and that's the white point of the display. And in prepress and printing environments, we are actually standardized on D50, because D50 is the closest white point of a display to the white of a paper, of a neutral paper. So that's why we choose D50. Another popular one is D65, which is recommended in this software because that's for photo. Okay, but we'll go for D50 instead. I will have Color Monkey to automatically determine the luminance level of my screen. And the luminance level, that's this here, when I go like that, okay? And what he's going to do is actually measure the light here in the room, in my environment, and then adjust the display to actually have that in an optimum condition, okay? So let's go to next. So I can turn this wheel for various applications. If I'm profiling a screen, it needs to be here. If I measure a printer profile, it needs to be here. Calibration is here. Luminance, will need that, is here. Projector is here, etc., etc. So software tells me that I need to go there. So let's turn it. Okay, and then we'll calibrate it. So inside of the device is like a white calibrated tab, similar to the one you see in here. But in the Color Monkey spectrophotometers, it's integrated. So it now asks me to turn it this way, like this, and it's going to measure the light in my environment. So measure, and you should keep it as close to your screen as possible. So he measured it, and he says it's 525 lux, and my screen should be set to 88 candela per cubic meter. All right. only if you have everything on green you can proceed. What it doesn't say here, this I need to put it into its neoprene jacket the correct way, because otherwise I can't hang it on my screen. All right, so I'll put it in there, close it like this. Oh, and also make sure that this is open. Sometimes when you put it into the jacket, you accidentally close it, and what he does then is he starts measuring colors, but after 6-7 colors, gives you an error. So next, he asked me to position it on the screen, and he looked for the center of the screen. So I'll take this. This is like a counterweight. It's like a BB bag. So you can hang it onto the display like this, as flat as possible. We'll click next. It will tell me that it needs to be as flat as possible. Laptop screens are a bit tricky to put them nice and flat because you have a quite small panel to put it onto. Okay, so it's on there. And what he's going to do first is calibrate the luminance and the contrast. So pretty soon we'll have green bars and orange bars, and he will ask us to change the luminance, and we can adapt it. So I'm into the green for the moment, but you see my target is 88. That's what we had from the luminance measurement of our environment. But right now my screen is emitting 142 candela, so I need to bring that down. So I'm going to use my keys, and you will see that it adjusts 125. Also a good idea, if you clicked once, wait a little bit again, watch it go down, and usually it goes down twice. So it's 95 now. I think if I go down now, it'll be too much. Well, 86, no, 77, that's too much. So let's go up again. Right. And of course, if you have a screen with precise controls over contrast and brightness, because that's what I do now, I change the brightness, then you can get this orange indicator smack in the middle. Okay, I'm gonna have to settle with 95 candela, because if I go down, I get 77. If I go up, I get the wrong way anyhow. All right, so I need to settle for that. Next. And this will take approximately 5 minutes to measure every color that the Color Monkey software throws on my screen. So what it does now, actually, the Color Monkey software has this list of predefined colors in LAB, not in RGB, not in CMYK, in LAB. And it tells the computer, show me this color. And then the computer, the Color Monkey device will measure what is displayed and compare it to what it should have been. Okay? And usually it's dead wrong. So he'll build a table of, this is the color I need, this is the color it showed, and this is a correction. And this table will be saved in the display profile. So that's actually nothing more that happens. Of course, he also writes the luminance settings in there, but basically it's a table with values. Okay? So the i1 Pro, and since beginning this year, I believe, we also have the i1 Pro 2, which replaces this one, can also be used to calibrate the screen. And if you put, it uses different software. It uses i1 Profiler software. But if you go through the i1 Profiler software for screen calibration, you will see that the functionality and the features you get are exactly the same as this software, as long as you put it in advanced. You can set the luminance yourself or have it measured by the device. You can choose the white point that your screen will use, D50 in our case, etc., etc. And it also takes 5 minutes, by the way. Okay. So I got a little time to display other options like this color checker, for instance, that you get with the Color Monkey Photo, which is available, by the way, as an option for any other device made by X-Rite. What it actually does is, or how it is used, is that you will take a picture next to the object that you want to take a picture of or a photo of, be it a model or a product or a plate with food, doesn't matter. You hold it next to it, you take the picture, then this is your reference image. And later on, when you load your photos into the software, he will measure what was taken by the camera, compare it to the values it should be, much like what he's doing here now, and then build a profile for this particular digital camera in that setting, in that environment. Because, you know, in photography, even studio. So that's where the color checker comes in very handy. Like I said, by default, digital cameras use Adobe RGB or sRGB. Should you, I mean, depending on what you do with photography, for instance, if you do food, then yes, I would definitely go with that. If you do models and fashion, I would go with that. But for all the rest, I would take Adobe RGB as the profile assigned to the images, and have that as the profile that will be used to calculate from towards the printer. Okay, so-called input profile. So I think he's nearly there. Under 1 minute remaining. I'm sure you saw some colors passing by that you said that's an interesting color. I still haven't found a way how to capture these colors and make a palette out of it that I can use in Photoshop or Illustrator. Sorry, there's a very nice orange in there. Right. So we're there. We'll take it off the screen, put it on side, and I'll put this one back here. And I'll switch you back to our default setting here. So you can see my screen again. Here I was. So I'll give it a name now. And what I usually do is I put the device, which is a MacBook Pro, underscore the date. I think we are 29/10/2015, and the luminance. Okay. And I'm going to save that. And as soon as I save it, on the Mac, he will also apply it as the profile for my screen. So save. You will see the colors of the screen change. Too late. I don't think you see it much in the shared view here. Maybe a bit. All right. And I should set a reminder to reprofile this display. And you have the option between every week, every 2 weeks, or 3 weeks, or 4 weeks. And the recommendation for X-Rite is every 2 weeks. And my recommendation, if it is an LCD, is every 4 weeks. 2 weeks was great when we were still working with CRT displays, cathode ray tubes, you know, the big bulky ones with you need 50 centimeters in the back to put them on your desk. These, the phosphors used in these, they age much faster than an LCD. And there, every week, every 2 weeks was like an absolute minimum to reprofile your display. With LCDs, 4 weeks is fine. So next, now we can compare before and after. Like that. I'll make my screen big again here. That. Right. So this is after. This is how it was before. You see the entire screen change. It gets much cooler before because the standard profile for this type of device, this Mac, is based on D65. And after, you will see that the color gets warmer. But if you pay attention to this, right, if you set it here before, then it's bluish, all right? And after, it gets much more neutral, and that's what we want. In any profile that we make, whether it's calibration of a screen or a printer profile, we want neutral grays, because neutral grays are the guarantee that the colors printed with that specific printer or viewed with that specific monitor will be neutral. If the grays are neutral, the rest is neutral as well. So we're done, and we come back to the opening page of the Color Monkey software. All right, back here, and here, and here. So now that we have a calibrated screen, I'll quit this software and go to Photoshop and verify that I have the profile I just made set for my screen. Here it is, displays, color, and I have it. I made one this morning already. I have this one now. So now I know in Photoshop that what I'm looking at is correct, is to be trusted, okay? And if I now do soft proofing for my Mimaki GB33 printing on with Rama, so proof, colors, yeah, I know that if I print it, it will be very, very close to what I'm seeing on the screen now. So I don't like it much, this image. It has a lot of posterization in here, but at least I can start to do my color correction in a way I can trust. So let's have a look on the profile we just made. Yeah, color sync utility, that's the one I wanted. Yeah. So the one I made is here, okay? And that's the gamut or the amount of colors that can be displayed by the screen, okay? So we hold this and we compare it to our profile for the Mimaki GB33 with Brahma, then you will see the gray is my, the grayed out is my screen profile I just made. And what you still see in color is the colors that belong to the Mimaki GB33 with Brahma profile, okay? So you'll see that there's quite a bunch of colors that can be printed, but not viewed on the screen, but there's much more colors I can view on the screen that cannot be printed. If we do the same for Adobe RGB, this is Adobe RGB, and we'll superimpose our Mimaki GB33 with Rama, then you'll see that this area of colors that can be printed by the Mimaki GB33 has become much smaller. And if we do the same for sRGB, we hold it again, and we compare it to this one, then you'll see that this area is much larger. Okay, and finally, there we take sRGB, we hold it, and we click on. Well, you can't even see it anymore. So clear, we'll go to Adobe RGB, hold that one, and go to sRGB. And so the gray is Adobe RGB, and the colored one is sRGB. And you can see that Adobe RGB is a much bigger color space than sRGB. Okay. So see if there's something I forgot, but I don't think so. So I'll open the chat. I'll end the sharing. I'll open the chat so that you can ask your questions. Chat is open. Now, what we didn't cover is, because this is basic color management, helping you to understand what is involved and what is used, etc. We didn't go into printer profiling, and you can do printer profiling with the Color Monkey and with the i1, but there's a big difference. The Color Monkey can profile any RGB printer, while the i1 can profile CMYK printers. And what is an RGB printer? Well, an RGB printer is any printer that has a printer driver installed on your computer. So, I don't know, your desktop inkjet printer, that's considered an RGB printer. And the reason for that is that all these desktop inkjet printers, but also the Epson printers, the Canon printers, the design jet printers, they do the calculation from RGB to CMYK in the printer itself. And therefore, they are considered to be RGB type printers for your computer and for your software. All right, questions, please. Chat is open. Don't be shy. And as usual, you can watch the entire webinar and any webinar we did in the past again on our YouTube channel. Just type DigiPrint Supplies when you are on YouTube, and you can see all the videos and webinars that we have done in the past. I just answered, Freddie. So there you go. You can watch it as much as you want. Right, any other questions related to this? Now, a little side note on soft grouping, what you saw me do in Photoshop. When you are in large format printing, you use a RIP software, and most RIP softwares allows you to create printer profiles. Some don't, like VersaWorks, but most of them actually do. And what they actually do is combine a linearization file and an ICC profile into something they call an imaging configuration if it concerns Wasatch or a color set or whatever. And the big problem with that is that you can't get the ICC profile out of it. So if you can't get the ICC profile out of it, you can't install it on your Mac or your PC to do soft grouping. I have learned that a lot of the media suppliers, MacTac, Rama, and so on, if you request the ICC profile, you can't get it. All right, just have to say I'm using this type of printer. If they don't have profiles for any printer that is out there on the market, but if they have the imaging configuration or color sets for a specific printer and media and RIP, you can request the ICC profile, and some of them give it to you and some don't. Okay. But you need them to do soft grouping. Yes, Steve, we will in the future do a webinar related to printer profiling and everything that is involved in there, where you can learn more about how it is done, what you should pay attention to, what is under color remover or UCR, what is gray color remover, GCR, etc., etc., and what are the standards used there, and especially how you can make this easier. Okay. RGB is a type of color reproduction. It's red, green, blue. sRGB is a monitor profile, if you wish. It's a color space. Okay. And sRGB is said differently. It's a collection of colors, while RGB is a spectrum. Any other questions? Selma Bouvier, nice to see you again. You're welcome. You're welcome. They are both considered CMYK printers, Juan Fidel. The printers of Epson that are considered RGB printers, well, basically it's not that hard to understand whether it will be seen as an RGB or CMYK. Is there a printer driver or not? And the GS6000 does not have a printer driver, or at least not to my knowledge. So anything that is Stylus Pro, Stylus Photo from Epson, their typical proofing printers are considered RGB printers and can be profiled using a color monkey. A lot of these printers that are intended as a proofing printer have X-Rite hardware built in, have a built-in spectrophotometer that actually, when you print something, there's a small band of colors that is printed just before it. So it prints that, pulls it back, reads it with a built-in spectrophotometer, does some adjustments if necessary, and then prints your file. Yes, Richard, as I explained, you can use the Color Monkey for profiling your monitor and for profiling RGB printers. Unfortunately, you cannot use it if you use a Roland Uto or Mimaki printer because that's not considered an RGB printer. And then you need an I1 if you want to go that route. If you want to make your own printer profiles and not rely on the ones that shipped with your printer or were given to you by your media supplier or came with the RIP software, and you want to make your own profiles, then you need an I1. Yep, it is, Richard. You're welcome. No, Ali, what you should do, that's actually a very interesting question, is work in RGB for as long as you can and do the conversion from RGB to CMYK at the very last moment. So in real life, that means that you're going to convert from RGB to CMYK in the RIP, or have your printer do it if it is an RGB printer. And the reason for that is, as long as you stay in RGB, you have a much larger gamut of colors to work with. So let's say that you have a photo and you open it in Photoshop and you go immediately from RGB to CMYK and then you do your color corrections. What you actually did when you went from RGB to CMYK is already taking out some colors, changing colors because you saw them changing on the screen when we did it in Photoshop with soft proofing, and then you start doing your color correction. Don't do that. Keep it in RGB, do your color corrections, and then look how using soft proofing, and then have your RIP software do the conversion from RGB to CMYK. So stay in RGB as long as you can. Now, your monitor only needs one profile, which is a display profile, the one we just created with Color Monkey. If you want to use soft proofing, then yes, for every printer and every media, you need a profile to be able to do soft proofing, like I did in Photoshop, where I choose the Mimaki GV33 with Rama, and the first one I had was Euroscale coded. So for every printer and every media, let's say that you have a Roland printer and you're printing on canvas, vinyl, and paper, then you need 3 profiles. And if you print on paper sometimes in this resolution and sometimes in the other, then that's also 2 profiles. So there's a lot of difference, and that's why the follow-up webinar showing you printer profiling, how you can limit this with the amount of different profiles that you need, would be interesting. On a side note, that's actually how we were working in traditional offset printing. Okay, you had a printing press and a type of paper and ink in there, and then you profiled it. And if you had to switch from one printing press to another, then again you needed a profile for that printing press, etc., etc. So at a certain time they said, let's turn it around. Let's make one profile, right, and have that ISO certified. And what you need to do with your printing press is bring it into the tolerances of that profile. So instead of having different profiles for different printing presses and media, you had one profile, and the press just had to adapt to be able to print like that profile. We don't have that in large format printing yet, because well, an offset press doesn't have that much difference in papers and in white points in the papers used, while in inkjet printing, you do have media that you simply cannot compare. Poster paper, for instance, and mesh, that's something that you simply cannot compare. Or canvas, and Hannemüller canvas, for instance, and a Rama vinyl, there's no comparison. They have a completely different white point, okay? Now, if you have an X-Rite i1 Pro, then you can do both the monitor and the printer. Good, guys. Announcement. Starting next year, we will change our concept of the webinars. We will split them in 2. we'll have something called Digiprint University or Academy or College, we don't know yet, which will be a series of trainings on everything printer related. It will be like 9 sessions targeted towards operators, okay? And we'll teach them everything from print heads to maintenance to anything involved with digital printing. And next to that, we'll have something called the Engineer Club, which is a discussion group for printers, for people that work on printers. So that's something that you can look forward to next year. Of course, we will have another webinar next month, and we will have a mailing sent out to you guys explaining how we will do this and what the purpose is and how you can sign up to join that. Thank you very much for being with us today, and I hope to see you again next month. Cheers.